your first day here, you've already been here. I love that, you know? Yeah, very cool. So, yeah, like, if you have an interest in Linux, we're definitely a cool place to be. Previously, when I wasn't teaching the class, I was doing other forms of hacking. You have AT&T Fiber at home?
Yes.
Aha, you missed that one. So we hacked the AT&T Fiber system. I extracted the certificates off of my box, and now I connect to it directly through an OpenWRT router. So that was a prior project. So we do some kind of projects like that in between classes. And those aren't planned. Usually I have a backlog of shit I got to get done, and I come and I do it live. So your mileage may vary. Sometimes it's interesting, and sometimes I get nowhere. But yeah.
One quick question for
Definitely.
you. I have been part of the Linux Discord for quite a while.
Cool.
The Rust YouTube videos that you mentioned, are they already in there, or what would I look on YouTube?
They are all in the hashtag Rust channel on the Discord, yeah. And what's up? No, they're just in the Rust channel as far as I know. They may also be in media. We have Jonathan now coming in, so we got one more. Someone needs to go open the door. Cool.
You want to catch the door?
Appreciate it, my friend. Marco should be on his way too, or I just heard him. Kai, I'm going to be showing off code that I wrote today in Rust. So we'll be playing with that a little bit later. I've decided to oblige your request. I'm going to open source a big project I made.
Finally, something practical.
Well, we'll see what you say after I show you the code. I think it's practical. There's nothing else that I know of that does it. And actually, it's interesting too because it runs on Windows and Mac, so it has that kind of like cross-platform stuff. But I had to write it for each different platform, so I actually had to write code on a Mac. It was a miserable experience.
No, I was thinking of C. I was thinking of C macros.
Yeah. We'll go over some of that at the end.
All right. We're waiting for him to come back.
My work has a thing called, well, they use a VPN. In order to log into that VPN, I have to use my cell phone and I have to use the Authenticator app. So effectively, I go to log in, I type my username and password, and then they page me. And I have to answer the page with the number on the screen or some kind of thing like that. And that makes automatic logging into the VPN very complex. So in order to circumvent that, the VPN software is called OpenConnect. They've kind of given up on that process. They've said, do whatever you want, just give us the cookie when you're done. So I made something that'll log into the different browsers through the back end, through the SQLite databases and whatever they're using, and extract the cookies from them. And then it'll give you the ability to drop that cookie directly into OpenConnect. So it's a cool tool like that.
That's right, the SQLite hacking.
Yeah, I've showed off different states of that project, and but I mean now I got it working on all different platforms, and I think the next big thing I do is going to be to support historical versions of the browser, so it becomes a forensics tool. So you could essentially take a browser that's like 5 years old and dump the cookies that are on it. Right now, I only work with the latest versions of every browser. It is the only way I can improve that I know of. But we'll get there. All right. So let's go ahead and kick this off. I don't think we have anyone else that I see in the parking lot, so that's good. We got everyone here. We have, in the last, it wasn't actually the last class, it was a couple classes ago, we talked about the documentation system in Rust. And I sold that off as something that I really like in Rust because it's an integrated part of writing a product for someone, and Rust does this really well. So what I liked about the documentation system in Rust is, as a programmer, all I do is add one more slash, and then suddenly that comment has a syntactic meaning to Rust. It doesn't just say I'm a comment, it says I am documenting the thing that I am above, right? And then Rust uses that to generate documentation with cargo doc. Killer feature. Rust does it right. Every other language that doesn't do it in that exact way is wrong, right? It is the best way to write documentation. So Rust also, I believe, has done testing more right than other languages, right? And I'm going to go over today why I feel that way, and we're going to see some examples of this. But testing in Rust is more or less a first-class thing, right? Rust has a notion of compile this code under this specific circumstance. When you run cargo test, it says this is the circumstance. I'm running this in test mode. So you can have code that only compiles under test mode. And what kind of code would you only compile under test mode? The tests themselves. So your tests sit in the same file, your unit tests sit in the same file, and they're only ever compiled when you run cargo test. They're not compiled under debug build. They're not compiled under your release build. But when you run cargo test, they get compiled, and they execute the code, and they have access to private functions. That's the only thing that makes them unique. And you can run tests on pretty much anything, you know? And there's a nice system for doing that. You compare that to like Python or Perl, where you have all your tests in a different location. It's a lot nicer of a system. So you have your tests now inside of your project, and what I don't recall if this chapter covers, but is really the point where you knock the ball out of the park, in my opinion, it's when it comes to documentation, right? So other languages, and we did cover this, I think we covered it in the first class, other languages have a notion of documenting how code works. Perl does this. It looks like a synopsis. I'll show you some examples here. If I go to MetaCpan, we go down right down here, and I look at something like, let's do moo. This is like an object system for Perl. I'm just telling you, like, here, this is a bunch of code right here. It says it right underneath synopsis. It's code, right? But there is nothing to show you that that code compiles or that that's how it works or anything like that. Rust has merged these two concepts of documentation, showing code, and testing, right? And there is a mix of the merger of those two things is doc tests. So you can write tests that document your code, and when you run cargo tests, you can have the test internal run. So that is, in my opinion, a really cool feature. You know, I can show you how the code is supposed to be used, and I can prove to you that that code works. And if you ever run cargo test and that code fails, it'll barf right there. So we're not repeating ourselves in between testing and documentation. I don't have to copy this code, put it in a test, copy that code, put it in a test, and then show that that code still works, and then run that every time. I can just write it once, and it'll test it for me. All right. So enough about why I like the system. Let's skip the introduction, words, and let's go down to how to write tests, the anatomy of a testing function. Let's make that a little bit bigger so we can read it. Let's close our sidebar. We don't need that. I don't actually like the sidebar until I'm past the halfway point. It's a little depressing until then. The anatomy of a testing function. So we have this pound, and then in the pound we have the brackets, and then we have the word test in there. And what we're doing there is we're telling cargo that when you are looking for tests, this is a test. And you might say, well, if we're putting these things in a specific place in the code, why do we have to say that everything is a test? And the reason is, in some languages you have test libraries, and they're a distinct notion. In Rust, you can have a test library, but you can also have a test library inside the same module as the tests themselves. So if you have a testing library, a testing function, then you don't want to run that as a test. You want to isolate that as a library that the other tests are using. So the hashtag test attribute right there says this is an actual test. Run this code and ensure that it does what we think. Here's an example where we have a public function called add. It takes two USizes, a left and a right. It adds them together, it returns a USize. Very simple add thing here. We would never write that code. Now, does anyone remember, because we did look it over, how that should be written? Because it's not more complex. It's actually very similar. But how would we write that code as professional Rust programmers? I'm only asking because we covered this.
We do it so that the function, the parameter can be any type.
Yes, but there's even a better answer than that.
No.
That's good. That's good. That's 100% right. But there's even there's one that's 105% right. TNU. No, that's not where I'm going with it. There is an actual trait for adding, right? This is not a trait.
Right.
This is just a function. So we have a trait that can add as well. And then when we implement the trait, you don't actually have to call add with two different parameters. You just call, left plus right, and Rust figures it out, does the rest. So for adding, we should always try to use a trait. But here we're adding not two things we're implementing, we're adding two USizes, so it makes sense. But there's already a trait for USize that does adding, so we're not doing anything. But we are showing you a very simple function, and now we're going to get down to how we test it. That's really the guts of this example. And here we have this pragma called configure test. This tells Rust that what we are compiling is only to be compiled under the testing configuration. So Rust has a different notion of configurations. You can provide the compiler and say, this is code that only runs on Windows 32. This is code that only runs on Linux. This is code that only runs on OS X. We are going to see some of that when I bring the code that I want to show later on. But this is saying this code only compiles when we're running it under test mode. So that module underneath it is what we're talking about. That whole module only compiles under test mode. Now inside that module, we are pulling everything from super in. Why super? Because now we are inside of test, and we want to get access to the things that are outside of test. So we can either do one of two things. We can qualify everything inside of test, or we can say, I don't want to qualify it. I'm testing the code above, outside of test. So we use this use super : asterisk, and now the thing inside of this module test can see everything in the scope outside of it. Does that make sense? So the scope test is like a subscope, a submodule, right? The thing outside of it, you want to be able to see, and you don't inherit those symbols. So you say use super : asterisk, and then it allows you to see those symbols. They're now available. So inside of this optionally compiled test, we have this one here marking this function below as a test. And the testing in Rust is super basic. There are complex testing libraries that do a little bit more, but it is very simple. So we have one assertion here called assert equals. It takes the left and the right, result for, and it's effectively going to say, are these two things equal? Right? There's a couple more features. We'll see them as we go on a little bit more. But these are just testing macros that Rust has. And there's really not that many of them. Here we're doing the same thing. We're doing exploration, and we're asserting that the left and the right side, the left is an expression now, 2 + 2 = 4, and we're just checking that equals 4. The code below, this example below, is actually showing you what it looks like when we test it. We call cargo test, and it says compiling adder. It says it's unoptimized, and it's adding debug info in it. Those are the defaults there. So a test build is a debug build that has optionally compiled testing code inside of it. And we run the test right there, and it shows you the test, the name of the test, and whether or not it passed or failed, right? That's the kicker. Now that thing underneath it, docs test for adder, there are no doc tests provided, so it says running 0 tests. There are also, if you have documentation tests, it'll show them separately. The more you write Rust code, the more you want everything to be a documentation test, or a lot of it to be a documentation test. Because then you're showing people how to use your code in the same time as you're testing your code. So there's very seldom a reason not to want to do that in the right way. Now we add another test, but this time we'll make a test that fails. So now we're trying to test that something, we're trying to show what happens when something doesn't work. So now we have this configuration test. We're declaring the test at the top. We already know the one at the top passes. So we declare this other one, another is what we call it. It's another function. And here we are calling panic. Now this doesn't pass an assertion equals. It panics, which means that we're going to throw an error. And when we throw an error, we're going to list that as a failure in the testing output below. So now we have cargo test. We see the another failed and exploration passed, right? And that's what it looks like to see the test runs. So it's a pretty good overview there. As you have more of these, you are only really interested in failures, and there are options to only see failures. Instead of OK, the line test, test, another shows failed. 2 new sections appear between the individual results and the summary. The first displays the detailed reason for each failure. So we can see here the reason for the failure. It's going to show that in the output. It is right here. Make this test fail. This is the reason why it failed right there. We panicked, and it gave us the name, make this test fail. So if we come up here, make this test fail is actually the contents of the panic. So when we're panicking, we're dying with this thing, and then panic is going to show the backtrace. Oop. OK. I'm not a huge fan of that page up, page down location. We have right here, right? So make this test fail is the thing inside the panic, and then we would see the backtrace there if we ran it with that Rust backtrace equals 1. So the backtrace doesn't show by default when you're testing, but you can make it show. And We also went through the backtrace before. The backtrace shows you where you're at and everything that you have to do to get to where you are, right? So if some function A calls function B, which calls function C, and then C panics, you're going to see C, and then right below it, right, you'll see B, and then you'll see A. As you go down further into the stack, you're going to see everything up to main, right? Checking results with the assert macro. Okay, so far we've seen assert EQ, which is whether or not two things are equal. We've seen panic, which is going to show that that artificially thing fails, right? And now we're introducing this assert, and assert is just going to do anything as long as it returns true, right? That's the only thing assert cares about. So here we have a code, rectangle, and we have can hold, and we're going to write a test here for can hold, and it says larger can hold, and we're simply asserting that the larger can hold the smaller. Right? So assert at that point doesn't know anything about its contents other than whether or not they're returning true. And when we run it, everything passes, we're golden. Okay, now we're asserting that smaller can hold larger, and of course that fails. And when it fails, it's the same thing as a panic, and I just hit the fucking button again.
How does assert output
1 second.
its result?
I'll show you that in 1 second. Boom. I don't understand who thought page down should take me to a different book page. I think that's.
It's taking to another chapter.
I think so, because if I go, no, it's not. It's not taking. It's just moving it up and down. So I just hit the other message. Okay. I don't know how I got to the. That's what's happening. Okay. So the left and the right arrow are taking me to different book pages. That is super obnoxious. Anyway, that's where I'm screwing this up. Okay, there's the assert macro one. I need one of those button clicker things, you know, that you just hit the button and then that's it. You can just has a page down, page up button, and no fucking arrows. I couldn't screw that up. What's up?
I thought I saw one in that corner.
Is there one? Oh, there is something similar to that. How does this thing work? Looks like someone stole the USB stick thing on the bottom there. But that's cool. Someone find me where that is on Amazon and send that link into the channel. That's an H-log expense. I'm gonna have to buy one. Okay, so we have smaller can hold larger, and now we're throwing the error. And now the question is, what does the error look like? Well, we know right away we're gonna fail. So if we fail an assertion, we're gonna have the option to list the backtrace. We are not gonna have the backtrace enabled by default, but it should show it here. Smaller cannot hold larger. So you see, this is what I didn't see right here. They're also asserting that it's not true. So this is returning false, then they're negating the false, that's becoming true, the assertion passes, right? We're asserting that the smaller cannot hold the larger. So we're testing the negative there. And because we're doing that right and the assertion passes, there's nothing there. Now, here we implement, we change can hold, and now we're looking whether or not self.width is less than other.width, and then self.height is greater than, so we're changing this. We're changing the implementation from self.width is greater than other.width to self.width is less than other.width. So we're breaking the implementation and we're going to rerun the test. We break the implementation, we rerun the test, and now we have larger can hold smaller failed, right? And now this is what it actually looks like when you fail that assertion. Now remember, this is assert, not assert EQ. We don't have additional information about a left and a right to show, so we're just going to show the name of the test that it exists in, smaller cannot hold larger, and we're going to show you the failure, and the failure is right here. So we get the name of it. This is the thing that panicked. This is every test runs on, I think, a unique thread. This is the assertion that failed. Larger can hold smaller. We can tell that because this is all generated through a macro, so it does have the names of the thing inside of it. So this is saying here, whatever this does, of which I don't think it knows, this thing is what is actually failing. And then again, it's giving us this. The Rust backtrace equals 1 to show the backtrace. So if this takes you right to the error, you don't need the backtrace, awesome. If you need the backtrace, you want to know more about how you got there, then you can enable that. Testing equality with the assert equals and assert not equals macro. Okay, so this is kind of nice. We had this notion of assert. We just did that, and we negated assertion when we were asserting something that we wanted to fail should pass, right? So effectively we're saying we want to make sure the smaller one cannot hold the larger one. So we did smaller can hold larger. We know that's going to fail. We negated that whole thing to make it return true, so the assertion would pass. Now we're seeing here we actually have assert equals and assert not equals. So we don't ever have to do the negation thing for assert equals to get not equals. There's a convenience method there that does that for us. So if you use assert underscore not equals, we can make sure two things are not equal. And that's very simple. It does the same thing otherwise than that. And we already know what the errors look like. We're just going to skip that part. OK, so again, we're breaking the implementation. This is a repeating pattern. And we get the same type of error. Now, one thing that's kind of interesting here is that because we're using assert EQ and assert NE, we have this left and this right side here that can actually show you not just what is inside that case, that assertion, right, which is right here. This is the code, but it'll actually, in debugging, give you the left and the right side. So anytime you're testing for equality, you want to use assert EQ because you get this additional piece right here. It tells you what the left side and the right side equals, which is nice. Adding a custom error message, OK. This is a great idea, and we should always do this. When we have an assertion, the first argument is the code that we're going to be testing. But the second argument is a description of that test. So far, when we've been looking at all these different assertions and how this testing works, we always just identify the test by the name of the function above it and the code inside of it. But we can give it an actual description of what we want to happen, right? I'm testing that this piece of code does this thing. This is in every testing library. They're always going to have this piece of functionality. Rust does too, and it makes it a lot nicer. And we'll see that used right here. So here we're doing the same thing with result.contains Carroll, but now look what we're giving it. We're giving it this, which is the format string, and then the stuff to fill it under. So when we see print ln, the first thing you provide to that is a format string. It's a template. Either one of those two things work. You can, depending on what language you come from, you'll have a different name from it. But that template is usually going to have something like this on it, right? You've seen this before when you're doing print line. This tells it where you want to put that variable, and we've went through this before. Does anyone remember what is required for that to work?
Variable needs to be a string.
No, it can be an object, it can be a struct. But if it is an object, if it is a struct, what are you required to do to make that work?
Display.
Boom, you got it, 100%. That's exactly right. Good job. Yeah, you have to implement the display trait. So you can provide it anything you want, but that thing you provided has to implement the display trait. So a string is just a data type. It's a struct, but it implements the display trait, right? It says, I want to print this out as if I'm a string. Well, your object, your struct that you're providing, you're creating, it can do whatever you want, but if you implement the display type, you can use it like this. So we know here that result has to implement that display type. Now, result.contains Carroll. What is result going to be? Dun 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 dun. Result.contains Carroll is likely going to be what? Not a string. True or false? Exactly. It's going to be a bool, right? It's going to be a bool. So result.contains Carroll is almost certainly going to return to us true or false, whether or not result contains the string Carroll, right? So what does this say? Result.contains is going to return a bool. That is what's going to tell us whether or not this assertion passes or fails. If it fails, we're going to print greeting, did not contain name, value was, and then I have this template in there, right? And I'm going to tell it here, I want to print out result. And result, whatever it is, and I can go up and see what it is I didn't see that. Yeah, right here. Result greeting Carroll. So greeting is right there. So greeting is returning a string. So yes, so result is a string, and we already know that the string implements display. So this is just going to return this, right? Carroll. So that's what this will be. So greetings did not contain name, value was Carroll. That's what it would say. Of course, this assertion passes, so result does contain Carroll, but if it didn't contain Carroll, it would say something else. Let's say you create a greeting and you're greeting Bob. It would say greeting did not contain name, value was Bob, right? That would what it would look like if it failed. Make sense? Cool. All right, so here we're implementing a struct. We call it guess, and the guess has one value. It has an I32 in it, right? So now the thing here is we want to implement for the guess a constructor. So we have a new constructor there. It takes an I32. Let's use a term here, right? We've learned this term. We're implementing a function on a struct. It does not take self. What do we call that function? Does anyone remember the Rust term for this? We call it an associated function. We differentiate. We talked about that a little bit, and what I said was, in Rust we have a distinction in the way we call things when they take self and they don't take self. Does anyone remember what that distinction is? If it takes self, you call it with a dot. That tells you, call the thing on the right of the dot, I'll use my hands backwards, with the thing on the left of the dot, right? Now, when you are creating an associated function called new, how do we call that? Clue, it's in the code, right underneath should panic. We call it with 2 colons, right? See it right down here? Right there, boom. That's how we call it. So we're calling it, let me knock this up a little bit so we can see it higher. We call guess : new. Not guess.new, guess : new. We call it with : because guess is the struct. We're calling the associated function new. New does not take self, therefore we don't invoke it on an object. We just need to tell it where new is located. Okay? So here we are creating a new guess object, a guess struct, and we're providing it to it a value of 200, this constructor. So we go up there, we're looking at that function. Now value is going to be set to 200. Is 200 less than 1? No. So that's not going to evaluate to true. Is 200 greater than 100? Yes. So we're going to panic, right? And it's going to say guess value must be between 1 and 100, got 200, right? So we're not going to be able to return the guess value because we panicked. This is horrible Rust code. You don't ever want to do this. Why do you never want to do this?
Panicking is bad.
Boom, that's it. You got it. That's a very simple one, right? That's in fact, anytime I ask you why you don't want to do this, if the answer is very simple, panicking is bad, you nailed it, right? You learned. Okay, so panicking is bad. Next step, what is the right way to do this?
Handle your errors.
That's close. I'm looking for something a little bit more specific, but yes. Try catch doesn't really exist, but what do we do?
Assert.
No? Assert panics. No? We return a result, right? So we have a constructor. The constructor is an associated function. The function is called new. Right now, the only option that new has is to return the object. But because new can fail, perhaps it's not a good idea for it to return the object. Perhaps it's a better idea for it to return a result, where one side is an object and the other side is an error. Then we can do exactly what you said, John. John or Jonathan? Jonathan. Okay, I won't truncate that one again. We can do exactly what you said. We can return the result, and now you can handle your error, right? So when you say handle your error, that is the right answer. Don't panic. How do you handle your error? You return a result. That allows people to do whatever they want, right? Now if I implement this library, and it's taking something from the user, and the user is a jerk, and he puts 200 in there, my library only handles numbers up to 100, I can then give that consumer of my library a result, and they can decide what to do. Maybe they want to panic, maybe they don't. Maybe they want to tell the user, you're an idiot, 200 is greater than 100, go down. You know? All right. But nonetheless, we have this horrible Rust code, and we're going to figure out how we're going to write tests for it. So we have an implementation for guess. It has a function in it called this function new. We have this panicking that's happening right here. And when we run it, what happens? Exactly what we said. We have this test greater than 100, should panic, failed. Now, why is this failing? It's failing because we broke the implementation. That's what I missed. That's the problem with these damn breaking implementations. I got to read the code. I can't just tell you what it does. So what did the implementation previously say? It said value is less than 1. That means we don't want to handle negative values or 0. When I say guess a number between 1 and 100, if you give me 0, you're breaking our rule. That's effectively what we're doing. I'm creating a struct that has a guess. I'm saying guess a number between 1 and 100. You can guess 1. You can guess 100. You cannot guess 0. Now, the prior implementation we had the upward bound. It said if the number is less than 1 or greater than 100, panic. We've now broken the implementation to where it says if the value is less than 1, panic. We're no longer handling whether or not the number is greater than 100. So what happens? Our test, which is saying that we should panic, right here, see what we're doing here? We have this test, and we say test should panic. Now we're giving it a number greater than 100, and we're not panicking because we broke the implementation, right? So they're showing you here, we have a method of testing code that we want to panic. So when you say handle your errors, yes. But if you want to provide something that absolutely can never be handled, and you want to use panic, you can still write tests for it. And that's where should panic comes in. There's also should not panic, which does the opposite. I believe anyway. But effectively, nothing should panic. Okay, so we have a notion of should panic, which is vague. Because what if you write super shitty code, and you do this everywhere, and in your super shitty code, right, you never give anyone the ability to handle your errors. All you ever do is panic. Well, then the question is, how do I know why you panicked? How do I test that? And that's where Rust says, well, we have a method. We'll support that too. And we have this thing here, should panic expected, and then we can give it the reason why we want to make sure it panicked. So if you have 5 different cases in there that can generate a panic, and you want to make sure this test fails because of just one of them, you can say this test should fail because of this panicked reason. Of course, in my opinion, all of this thus far is relatively useless because no one here is ever going to write code that requires panicking, so you never have to test that, right? That's the right answer. Okay. So now we get into the question of this result TE stuff, right? How do we test this in test code, right? Not all that complex. Let's see how we do it. So here we have a test that says it works, and 2 + 2 = 4. If it's OK, we return OK. Otherwise, we return the error. Right? Now here's the thing. If you decorate a function with test and it returns a result, Rust will look at the result and decide whether or not the test passes or fails. So you can write functions in Rust that are testing functions, return a result, and then the testing implementation in Cargo will say, this function you're decorating with test. This function you're decorating with this, I can't reach that high. Damn it, I should have had better genetics. This function you're decorating with test, right? It's returning the result. Cargo test is smart enough to say, if I get an error, I'm going to fail the test. If I get a result, I'm going to pass the test. So far we've seen different methods of doing this. We've seen functions that are decorated with test where we don't care what they return. And these functions, we determine whether or not they pass or fail based on the assertion. Assert EQ will panic if it's not equal, and it'll give you the errors. Assert NE will panic if it's not, if it is equal, and it'll give you the error. Now we're getting into how else can we write a test? We can write a test that doesn't rely on panicking, that has this result stuff in it. And what's really nice about this, right? We've seen this before. We have the question mark, right? Does anyone remember the question mark in Rust? It gives us the ability to bubble the error up. Well, now I can call any code that is returning a result, and I can choose to just simply give it that question mark at the end. And if I get an error, it'll let it bubble up and fail the test. That's nice. Another nice thing about this is if I have code that returns a result, and I just simply want to test that, whatever it's doing, the result that it has, I can write something that returns the same result and then just give it the code to generate that result. And it'll take care of everything. Right? And what I mean by that is, if this is the signature of the function, right here, result either returns a tuple for the result, for the correct half of that, or it returns a string representing the error. Right? If I have another function that I'm testing that has that same type signature, I can just simply call it underneath. I don't have to write any of this. I can just eliminate this to one line. And that'll work. All right. Does that make sense? Ask questions if it doesn't. All right. I also don't think that this is a hard chapter compared to the others, so it wouldn't shock me if there weren't too many questions on this.
What if you want to test for a panic?
Then we use the should panic, right? So we just went over that. There's this should panic. Checking for panics with should panic, right over here. This is testing some code greater than 100, right? This code here, guess new 200, should panic. So we decorate it with both test and should panic. That says it's a test, you should run it under cargo test, and then the code that is inside of this function should generate a panic. If it doesn't, fail the test. Cool? Okay, running tests in parallel or consecutively. So here we introduce this thing called threads, and this is an option. And this gives us the ability to run more than one testing thread at the same time. So tests don't share state. So you can look at every different compiled test as doing one thing, and you can run those tests in different threads. And Cargo has the ability to do that. So if you have 8 different cores on your laptop or whatever, you can run, test threads 8 and run through your testing suite 8 times quicker. Print returns a 10. So here's a function. It does nothing but print and return a 10. And now we're going to test it. So we let the value equals print and returns 10. And I assert that the value is equal to 10. And then I have this one here. This test will fail. I do the same thing. I'm calling print and returns 10. But now I'm giving it an 8, right? And it doesn't make a difference what I give it, because it only prints that 8 out. It always returns 10. So the value in both of these is going to be 10 because that thing highlighted never changes. It always says 10. So now I'm asserting that 5 is equal to the value. The value can only ever be 10, so this test is going to fail. And they're showing you here, this is what it looks like to have 2 different tests in a module. So now I have this test will pass, OK. This test will fail, failed. And it tells me what's on the left and the right side. We've already seen this. Now I have cargo test show output. So here's what they're trying to show here. When you call print and this kind of code debug inside of your test, you don't normally see it. That gets concealed by the test runner. If we wish to show that, we call this show output function in cargo test. I will say I found this to be tremendously confusing learning Rust. Because very frequently I wanted to debug my stuff and I'd forget that argument would exist because I never had it in any other language. I think it's an insane default not to show the output anyway. But the end result is you just get used to it. You call -- show output. Right? I think it would have been much better if there was, if that worked with the verbose flag. In fact, I even filed an issue. I said it was insane. And it's got like 300 likes on it or something crazy. My argument here is that cargo test has a -- verbose flag. But if you enable -- verbose, you expect it to show what it prints. It doesn't. To see what it prints, you have to call show output. I hate that. But that's me.
Evan, do you have
Little
to
bite.
write a different test for every path through the logic of that section of code?
No, you don't have to write any tests. There's nothing that will make sure your code is tested. I will say that the ideal in Rust is to test every public function code you want to support.
But that function has different logic, like depending on what you feed it, right? It could go through different sections of the code.
Right.
Through, if statements and whatnot. So would you have to write a different test statement for each of those conditions?
No. You don't have to write any test statements, so the answer to that is of course no. But I think a better answer to that is, well, what should you write? And my answer to that is, you should test every reasonable input you expect your function to get. So if you expect your function to take an input of a string that's a name, you could test the name Mary, and if you don't want it to pass with a number, you could test the number 6, and then say, I want 6 to fail because I expected a name and I want Mary to pass. And then that is sufficient for that function.
Right.
All right. Running a subset of tests by name. So far we've run cargo test and it runs every test. Now we see that we can run a test by name. What are the names of the tests? There's simply the names of the functions. So if I call cargo test and I give it add 2 and 2, it will allow me to just test that add 2 and 2. So here we're going cargo test 100. That is only going to test this test right here. Very simple. Now, we can run multiple tests. You can give it multiple names on the command line. It should also work. Here's a special one. This is kind of interesting. There is this notion of an ignored test, right? And what we're doing here is we have this flag called ignore. This means that we don't want this test to determine whether or not the testing suite passes or fails. So we can ignore the test entirely and save the code for it. This may be useful if you want someone else that gets paid less than you, or that you don't like, or one of your inferiors, to go make these tests work, right? So you can just mark the test as ignored and then flag it for them to do with their valuable time. Cargo test -- ignore. This will test the ignored test. I'd never see a reason to do that. If a test is ignored, I don't want to bother with it. The guy that is going to fix the test would run that code until he makes it work. So that's, someone else. Test organization. Okay, so now the question is how do we want to organize our tests? So far, we have created this module under every file, and we say mod test, and then we say always use super, : : use everything, all the symbols that are available above. But of course, there are other ways that we can organize tests. And one of the other methods that we can do it is with this concept of an integration test. So let's talk really quick about testing. Who knows the difference between a unit test and an integration test? Kai, you want to hit it off? Start the conversation?
The unit test would be testing 1 + 1 = 2. Integration test would be you want to test your. Well, for me, real world example, I want to I want to automate the login process to my brokerage. So I write a test that actually makes the call to login, but it mocks the HTTP call.
Yep.
It generates a fake response. I test that response actually passes.
Oh, that's a complex one. You were almost totally right, in my opinion, until you entered the concept of mocking. So I'll give you my definition of these two things. And of course, like everything, there's different definitions people may use. I would say if you're mocking something, it could still be a unit test. An integration test, in my opinion, is very explicitly about testing how your code integrates with something else you don't control. Right, so if there's something out there you don't control, like you're logging into your brokerage, you want to test an API or something like that, like Charles Schwab or whatever, now suddenly you're in the world of, I don't know what the fuck they're going to do, I have no control over it. So you're testing how your code integrates with their code. That is, in my idea, an integration test. If you're mocking it, I don't necessarily know, because now you control everything. And I don't ever mock. I hate mocks. I think that they're a horrible idea. I don't ever see the purpose of them. So,
keep hammering their login system and generate a bunch of extra login tokens, they'll ban.
Which is understandable, but if you have a mock, the second you introduce that, you're not testing what you think you're testing. You're testing your mock.
You save the actual live response, so you know what the actual responses are, and you reuse those responses.
But the second you do that, you have no idea whether or not they change their response, I'm not saying it's a bad approach. I'm just saying the drawbacks of that approach are you only are ever testing your mock.
Yeah, ideally you would want to apply it.
Right. Sometimes it's required. He gave me a reason why it's required. There's a quota. You can't log in an infinite amount of times. You can't run an infinite amount of queries. So in order to not get yourself banned, you have to mock it out. The only thing I would say is I would simply rather not run the test at all, because if I'm going to make an assumption that the response stays the same as when I ran the code the first time, what's the point of automated testing? The point of automated testing is I can rerun my testing suite and make sure it still works. The second I'm taking a snapshot of their response and I'm assuming it hasn't changed, I've broken the axiom that I'm writing this stuff for, which is being able to periodically retest it, But I'm in a company that forces you to mock shit. So, and they make fun of me all the time for not taking my job seriously, because I don't take the mocking very seriously. Like I'll make everything very simple and it'll pass all of their procedures, and then someone will come and say, I made it overly simple. I should show some of the complexities of their system. I should implement in my mocking the ability to fail, 1 in 100 times or something. It just gets crazy. But yes, testing is a very subjective thing. Okay, so we have this thing use adder here, and we're saying it adds 2, and now I have this. What they're trying to show you here is that I'm no longer writing tests in the same module. I'm now putting them into this integration test thing. Oops. And integration tests, which are right here, they're in this directory called tests. There's one thing special about the directory tests. When you run cargo test and you're testing things that it finds and tests, which it'll do automatically, you don't have to decorate things inside with that CFG test. The testing directory is special. It only gets used when cargo is running things with the test mode, right? So you save one line. So you can pull out tests and put them here. There's one other area where integration tests are really useful, and that is when you're testing even an integration in your own code base that requires 2 different things. So a unit test is good if it's in the same unit that you're testing. But if you're testing 2 different units, even if they're units you wrote and how they work together, that could still go better as an integration test. Because now you'd have to pull in code from 2 different parts of your library, or your package. So we run cargo test. You'll see now we have this thing right here. We're running test integration tests. And it does the same thing. Running 1 test, it adds 2. OK, right? And of course, we're not yet doing doc tests. So now we get down to submodules and integration tests. So we have this. This is effectively like a library, right? At this point, we're doing testing libraries. So we have test common.rs, and I'm putting this in this library function setup. And this may be some things other integration tests want to use. This may do things like log into a brokerage as part of the setup for the test. Test common mod. Don't ever do this. We already talked about that. The same thing appears, in my opinion. You create test common.rs. Oh, OK. Well, this is something I just learned. I had no idea. To avoid having common appear in the testing output, instead of creating test common.rs, we'll create test common mod.rs. The project directory now looks like this. That is one benefit to writing, I guess, a mod.rs. It makes sense there. Really, this is a piece of minutia. I didn't know about this. Don't worry about it. OK, so now we're in the integration test. And what we're doing is we're saying mod common. This is going to pull in that common library we created. And now we have access to it right here. So I'm saying common setup. Now, one important thing is if common setup fails or has assertions inside of it, they will all run as if they were directly written, expanded there. So your library, in our case common.rs, can include its own assertions inside, and they will get run anywhere it's used. All right. And that's it. So we're done with testing. Before we move on, does anyone have any questions on testing with Rust? I will say right now, we spent less than an hour and we went through pretty much the entirety of testing with Rust. That's a pretty remarkably low difficulty level for code testing,
You say it auto-generates stocks. What the test?
Auto-generates what?
You say there's some automatic generate documentation.
Yes, yeah, OK. Let's cover that. So the question is about the automatically generated documentation. So I don't think we covered that in this, which is kind of shocking to me. Yeah, we didn't cover that at all. So that means that it's probably covered somewhere else, and let's take a look. Nope, okay, let's see here. Rust, documentation, testing. There we go. So here's the deal. We talked before about how 3 slashes says I'm documenting the thing which I am above. You're documenting the code below you. That's the 3 slashes. That documentation that you're writing is actually Markdown, which is super cool. If you've ever worked with a language that doesn't have Markdown, this is definitely amazing. And it's not just plain vanilla Markdown. It's actually called Common Mark, if anyone knows the difference. So this allows you to write tables inside of your code, and you can do pretty much everything you could otherwise do in like a Stack Overflow question. It is like that. It has GitHub flavored Markdown, Stack Overflow kind of Markdown in it. It's super nice. Has anyone here ever written a question on Stack Overflow? Has anyone here ever used Markdown to write a code block? How do you write a code block with Markdown?
Inside of ticks.
Right. What do?
You create 3 ticks, and you put the language.
3 ticks. That's exactly right. And you put the language. That's actually even better. Now, we don't put the language in Rust. Do you know why?
There's no other languages.
Boom. You got it. You want to write another language in Rust? Fuck right off. No. But our documentation system does assume that 3 ticks is a code block. And inside of that code block, it will run it because it knows what language it is, and it just so happens to be totally capable. In fact, some would say the most capable of running Rust code. So when you call Cargo and you say you want to run documentation tests, it looks into the documentation, which is right here, with the 3 slashes, and then it looks for code blocks inside of it, and then it runs that as if that was a function in and of itself. And what it does in that function is it knows you're decorating the thing which you are above, so it has that information about your context. And if you write assert EQ, assert NE, should panic, whatever, on that code, then you tell your user how to use your code, what to expect, and Cargo test will test that code block and ensure that it continues to work as you'd expect. So if you ever break your implementation, or your documentation ever drifts away from your implementation, Cargo test will identify it, and it'll say, this no longer is telling your user the right thing. You need to fix it.
Would it be hard for you to live demo that?
Nope, let's take it. Nope, very easy. Let's take it here. So we are going to create a new library, right? Okay. Cargo new -- lib, and we're going to say hlug. Boom. We created a new hlug library. Now I'm in hlug, and I'm going to go into source, lib.rs, and I'm going to add into my library fn. Oh, we already have it. We have a function called add. Right. Now what I want to do is when I take this and I go cargo test, you see that my test works, and it says doc test hlug running 0 tests. Now I'm going to add a documentation test. Let me show you something else here. We're going to go all into this. I'm going to go cargo doc on this, and I can do -- let's just do that. That's good enough. And now it's going to give me the location of my documentation. I'm going to pop it over here, and we're going to see that nothing's there. Just has the function add, which is what it can tell. And under that function, the documentation will always generate the type signature of that function if it's public. It'll tell you. This is the default documentation for library, and it's showing me this, nothing much. Now, if I come over here and I say this function is used to add 2 U64s, and I write this and I rerun cargo doc, and I come back over here and I refresh it, now I get a definition of that function. If I come back over here, this function is used to add 2 U64s right next to the function name, add, right? Now I'm going to come back over here, and I'm going to show you how to use it. Now what I can do here is say assert EQ, boom, and then I can say here add 2 plus 2, like that, 4. Cool. Yeah. Okay. Now if I do cargo doc, come back over here, you can see here this function is used to add 2 U64s. I have documentation in the form of code right there. Now, I want to be able to make sure that this never drifts. So when I go cargo test, you're going to see here, oh, there you go. I already done fucked it up. Assert equals add.
Is the space there inside the parentheses? Is that a problem?
Inside the parentheses, no. Why is it doing that? What am I doing wrong? It's something stupid and boneheaded. It's not able to find add.
Assert EQ, you see the space in front of add, is that a problem?
No, the space is not a problem. No, that's not what it's complaining about. It's complaining that it can't find add. So let's see here. Oh, here, I know why I can't find add. It can't find add because I have to show people everything I would otherwise have to do is an end user. So here. So this is called hlug. So I want to just come down here and say mod hlug. I need to use the code first. And then it should work. Please. What? Consider importing the function, use hlug add. I don't know why that's doing that. Let's see here.
So you have to do like mod hlog at top of the file.
Yeah, but I already did that. Live coding is fun. The error, yeah, I can't find the function that we're creating. By the way, the other things that you're seeing here are kind of interesting. This stuff right down here should panic. This is the same thing that decorates the function when you write it. So that's how you write the other part of it. But this is a problem with the symbol, and it's just simply not showing that it's available. But we're declaring it as public. Public function add. Maybe this is not found in the create root.
If you go to the file,
What's up?
can you scroll all the way to the file?
This is the very top.
Don't you need to put mod hlog on the file itself, not just on the test?
No. You think that?
Or something like that.
No. In fact, that's not even going to work because you're in the same file. It doesn't exist. Maybe mod lib though from this. Can't find function add in the create root. Not found in the create root. Consider importing this function, use hlug add. Maybe that's the use hlug add. Did it generate me the right? Oh. Oh, there we go. Okay, that's what it wants. Okay, I'm confused about how to pull that symbol in. So yeah, so I can either say here use hlug add, or I can say right over here hlug add like that. Whatever. I think either one of those will work. Yeah. So that's how I write it. Now, let's take a look at this. Now I have this function here inside of the code block, right? And when I go cargo test, you're going to see right down here, the test result is OK, 1 passed, doc test hlug running 1 test, test source.librs add, line 2 is OK. So we're in the documentation test for add, and line 2 I have the assert equals, and it's showing you that it's OK. Right, now if I do the same thing and I go cargo doc, and I come back over here to our documentation, and I refresh it, you'll see it. Right, so use hlug add, assert equals add, and that's what it wants. So now I'm documenting the code, and when I run cargo test, it shows you it run. So if I take this code and I give it to a client, they know how to call my add function entirely. That hlug add is showing it from the perspective of someone using your library, not from your perspective inside the library. Make sense? So I'm showing them exactly what they need to use that function in my library. And I am giving them the ability now to see that documentation and run it as a test. And I can write more here. Like I can come down and I can say, here, you could even do something like I said, it's markdown. So you could say something like, there you go. So now I have a quote with the guy who ordered it. I need a function to add 2 integers, Mike. And I give you the definition of it up there. I think that I did this wrong. This should maybe look like this. There you go. This function is used that. So you can even write down like markdown. I have a header in there. I have a block quote. This adds 2 integers. I have the code documentation. And whenever I want to run cargo test, it'll generate the test for it. Run it as a test right there. Doc testing hlug. Boom. And if I make it fail, I come down here and I say this is what they were doing, right? 2 + 2 = 5. Now you can see what it looks like to fail the doc test. Now the doc test fails. And if I go cargo test, it shows you, not cargo test, cargo doc. It shows you the code below. So it didn't tell you that the code failed here. But if I come down here and I run cargo test, it tells me I'm generating documentation for code that fails. One other thing that we can do that the book didn't show is this backtrace equals 1 thing. If I add this to my command, you'll now see the whole backtrace for it, right? So you can see what happens. We're in main, then there's this hidden function called doc test main, and then it has this panicking assert failed right here. And it talks about what you did to get to it. This isn't all that useful because our code isn't complex. We're not doing a lot of things to get to the code. So it's actually just showing you core stuff, but that can be useful, you know? One other thing that I would show is, that's pretty much it. You know, it's just not that complex. Does that answer your question about live coding the documentation test?
Oh, yeah.
Cool.
Well, sometimes when you explain things and you're just using your words, it helps to see it in action.
I agree.
So.
Yeah, no, it's good advice. Cool. And to drive it home, that's where I showed you that code from Perl, and I said that this is a much better way of doing it, you know? Because this code here, the implementation can drift away from the synopsis and you'll never know. Whereas if it was written like Rust, if the implementation ever drifted away from the doc test, you'll immediately know. You have a way to audit it.
Then how do you know which documentations are tested, which one are using?
Every code block that is in Rust documentation is tested, but they don't all have assertions in them. So if I remove this, if I just show this, let's say I do this. Now the code is run, but there's no assertion. So when I do cargo test, there's nothing for it to test, right? It says it's running it as if it was a test, but there is no assertion inside of it. so you'll never know. If I come down here and I say 2 plus 2 equals 5, now I have code, but that code can't fail. There's nothing that's going to elevate that false to a panic. The assert EQ is what elevates that which would otherwise be false to a panic. So I have this piece of code here. Add 2 and 2 equals 5. That's going to return a Boolean. Add 2 and 2 is going to return 4. 4 equals 5 is false. Equals, or whatever. Equals 5 is false. So we're going to have a false there. Nothing is going to make that fail. If I come down here and I say assert, now I have a case that will elevate that false into a panic. And when I run cargo test, I get the failure. Now, we don't normally do that because the assert doesn't have the information. Look at this error here. You see how it doesn't say left and right? It literally tells us just this, failures. It doesn't show left and right. That's why we always use assert EQ. Now if I do this and I say 2 and 2 comma 5 and I run this, it tells me what the left and the right equal. There's more information. So we always use assert EQ or NE whenever we can. Now of course, this is a test I'm trying to show you would make it fail, but if I wanted it to pass, I just say assert NE. Now I'm testing that 2 plus 2 is never equal to 5, no matter how you implement it.
Say you're writing a machine learning library, and you want to document a training function call that loads a file, and you document it with a non-existent file.
Yeah. You have to document it with an non-existent file usage.
Document how to call a training function that loads a file and trains it.
I just wouldn't use assert on it. If you don't have the file, you can't ensure it exists in the documentation test.
So it will run it and it will try to load the non-existent file and panic.
It doesn't make a difference if it panics. If there is no assert, I don't think it, well, that's a good question. That's actually an interesting question, Kai. So his question is, if I do this, will this trigger a failure in the test? And it may. I don't know the answer to that. Yes, it does. So how do you write a code block that doesn't, okay, I actually have an answer for you. So yes, this would fail. You can't run code that panics even if you don't use assert. What you can do though is simply ignore. Now it will not run that code. So remember, we had the opportunity to decorate that function with ignore or should panic or something. We can do that here. I can say ignore, don't run it as a test, or I could say here, should panic, and now it'll actually make sure that that code panics. So those are your options out of that trap. In addition, there probably is a method to say don't run it at all. And I don't know if that method is just simply ignore or not. I think ignore is fine too. But no run. Bada boom. The no run attribute will compile your code but does not run it. This is important for examples such as here's how to retrieve a web page, which you'd want to ensure compiles but might be run in a test environment that has no network access. So the difference between ignore is that in ignore you have an option to run that code with -- ignore. With no run, you don't ever have an option to run it. It's effectively there that just doesn't run. So an ignore attribute tells Rust to ignore this code. This is almost never what you want as it's the most generic. Instead, consider annotating it with text if it's not code, or using ~s to get a working example that only shows part of the code you care about. So that's another option. So they're telling us that ignore we should never use. We should use no run to say don't run this code, or we can leave it like this, and if we have code that can panic, just precede it with a #, and then it won't run it. It made a liar out of me. There we go.
So what did you do?
If it's not code, we're using pounds to get it working example. I just precede it with a comment. So if you precede it with a comment, it doesn't run it. I don't know why this actually says pound. I'm guessing this is actually a typo. Comments in Rust are using //. So yeah, I don't know what the deal is there. That's not going to work. I think they're coming from a different language. Anyway, Does that answer all the doc test stuff? All right, let's move on. So now the next chapter is the I/O test. Writing automated tests? No, an I/O object, building a command line program.
Looks like a big one.
You don't want to do it today, or you want to do it today? Hands up if you want to do it today. Not even 50%. That's it? Only got 2 people that want to do it today? You guys got way the fuck outvoted on this one. Hands up if you don't want to do it today, just for confirmation. Okay, most people don't want to do it today. So let's talk about some other things then. We have some time. Let's pause the recording. Let's take it off because I'm going to show some stuff that I don't want public yet. And then we'll come back and we'll do some other things, you know.